this is Unit 7.2 continued. This is part 2. Remember that in our coordinate proof from the notes yesterday, that to show that the diagonals bisect each other, you just need to show that they have the same midpoints. Okay, there's one last way to show that a quadrilateral is a parallelogram, and that is a combination of the two different ways. It is if we can show that two opposite sides, or one pair of opposite sides is both congruent and parallel, then we can say that it is a parallelogram. That one pair of opposite sides is both congruent and parallel. The reason for that is that if we know that they're congruent and parallel, and we were to draw this diagonal here, we could use side angle side to show that those triangles were congruent, and then we could use CP/CTC to show that the other sides were congruent, or that the angles were congruent, and therefore the sides were parallel. CP/CTC. But for our purposes, it's enough to say A, B, C, D. If AB is parallel to DC and AB is congruent to DC, then ABCD is a parallelogram. So I like to summarize these on my papers, especially tests and quizzes, just with the pictures, just quick sketches. So we know that if we can show that opposite sides are congruent, or opposite sides are parallel, both pairs, or we can show that diagonals, opposite angles are congruent, or we can show that the diagonals bisect each other, or finally, if we can show that one pair of sides is both congruent and parallel, we can prove that it's a triangle. Now, once we've used any of those ways to show that it's a triangle, then all of them are true. So once you prove something is a parallelogram, all the qualities of a parallelogram are true. And you can use those in proofs. It can be used in proofs or calculations. Okay, now we want to do some examples. Okay, so are the following parallelograms? Why or why not? And I'm going to just go ahead and draw them all as though they were rectangles. These pictures are not to scale, not to scale. And what I want you to do is to pay attention to the features that I've marked. Are things congruent? Are things parallel? What do we know about them? Okay, how about the first one? The first one, 12's equal to 12, 8's equal to 8, yes. Opposite sides, both pairs are congruent. Okay, how about the next one? For this one, we have opposite sides congruent, and we have one of the diagonals bisected. That's not enough.